technology is proposed for checking the data integrity, as well as enabling transparency of information. However, when if intrusion detection system, uh, it is there is an issue to find comprehensive and valid cyber security data sets, and this is the big challenge. Et le grand problème ici, c'est trouver la base de données, le dataset qu'on va utiliser pour évaluer le système qui se base sur le blockchain. Currently, the most cybersecurity dataset used in the performance evaluation of intrusion detection system are not simulated in blockchain-based IoT environments, such as KDD99, NSL KDD, botnet dataset, etc. So the challenge is what? The development of new data set to build a network intrusion detector under a blockchain-based IoT environment is one of the significant research challenges. Challenge 3 is about developing efficient consensus mechanism. So the most popular consensus algorithms used in blockchain are proof of work and proof of stake. This consensus algorithm does not take into consideration the capacity limits for the storage and computing of IoT devices. Okay? Ça veut dire quoi? Ça veut dire que les devices, les équipements IoT, ils ne sont pas adaptés pour utiliser le proof of work. Pour le proof of work, on a besoin d'une machine de calcul avec GPU, d'accord, pour résoudre le problème des fonctions de hachage. Okay, so there are many characteristics that should be taken into consideration when developing more efficient consensus mechanism for the IoT network, such as transaction processing rate, security service, quantum computation, and decentralized trust. So, a possible research direction in this topic could be related to developing a hybrid consensus mechanism that combines the advantage of consensus algorithms. And in addition, we believe that performance and security analysis of resistance to quantum computations is needed for developing efficient consensus mechanism for IoT networks. Okay. Now let's move to the next challenge. It's about blockchain-based software-defined networking for IoT net application. So the combination of blockchain technology and software-defined networking offers promising opportunities to address the security challenges of the IoT environment and make it more secure. However, several challenges remain for the practical realization of the blockchain-based software-defined networking, and in order to replace the existing schemes. The absence of strong cryptographic encryption schemes between the SDN controller and the blockchain database can result in a serious violation of confidentiality of communication. Okay. 5G enabled blockchain-based IoT network, since the information in the state and location of an IoT nodes contain the broadcast message could be captured and used for the privacy leakage risk, okay, of blockchain, and the blockchain will be more significant in 5G enabled blockchain-based IoT networks. And some interesting technology can be applied in this problem. For example, game theory and machine learning, privacy preserving scheme, etc. Okay, and hence conducting researches and developing more secure, efficient, and practical privacy preserving schemes using these techniques will contribute significantly to development of blockchain. Now let's move to another challenge: secure blockchain ledgers at the fog computing. Caching the blockchain ledgers at the storage spaces in fog computing technology is an efficient and cost-effective approach to reducing the latency of IoT-enabled blockchain, as well as traffic overhead in large-scale industrial application. So the fog computing, the following critical challenges need to be solved. So how to select trusted nodes at the fog computing for caching blockchain ledger? When the IoT devices request the blockchain ledgers, where cached requested IoT data. And when trusted nodes for computing are, are damaged, how to ensure the confidentiality of blockchain ledgers? So the last challenge is about developing efficient and privacy-preserving schemes. The IoT devices in blockchain-based IoT application have a group-based behavior and high frequent mobility that require new challenges in privacy preserving. However, some emerging cryptography techniques such as anonymization, mixing, and differential privacy can be considered to design an efficient and privacy-preserving scheme. To design efficient and privacy-preserving scheme using this cryptography technique, there are some critical challenges to need to be solved. The first one is how to optimize the computing cost for this mechanism, since the IoT devices are characterized by limited resources. How to add appropriate nodes to support differential privacy. Okay. To this end, this cryptography technique should be carefully designed to provide efficient and privacy-preserving scheme for blockchain IoT application. And this is my reference of my presentation. So this our paper, okay, and there are other references that we have published recently about the use of blockchain technology for IoT application. Okay, and thank you for your attention. If you have any question, so you are welcome to ask any question with any language that you prefer.
أشكرك شكرا جزيلا سي فراج، بارك الله فيك على المداخلة. وكما قلت إن شاء الله نتوقع يعني استجابة
مرحبا بك. Juste le son parce qu'il est très loin.
Le son est
Est-ce que vous... Oui, je vous écoute bien. Oui, je vous écoute bien.
Donc, j'ai fait une remarque et j'ai demandé votre avis. Ma remarque, c'est que...
Malware.
Ok.
Ok.
Donc, ma première remarque, c'est que parmi les domaines vous avez cités dans votre présentation concernant l'application de blockchain et IoT.
Ok.
Vous n'avez pas cité l'enseignement de manière générale, l'enseignement supérieur de manière particulière. Pourquoi? Parce que vous savez sûrement que parmi les applications égales de popularité dans le domaine du blockchain, c'est la simplification des temps. La possibilité de devenir une blockchain, mais en communication des temps. Ça, c'est pas mal. Ça m'a décidé ce matin. Et en demandant votre avis, c'est qu'on s'intéresse actuellement dans le domaine du blockchain de faire correspondre. Je voulais savoir est-ce qu'on est dans la bonne direction. C'est que on souhaite utiliser la technologie blockchain pour faire correspondre des demandeurs de travail, même des étudiants, des demandeurs de formation, des étudiants, avec des industriels. Je propose de nous communiquer. Et là, on souhaite utiliser le blockchain. Oui, est-ce que cette direction, est-ce que l'utilisation du blockchain est intéressante dans ce domaine? Et en plus, c'est-à-dire, le blockchain essaie d'éviter et de supprimer la personne tiers. 15%. Faire correspondre les industriels avec un demandeur de formation. Est-ce que le gouvernement et l'université ne peuvent pas être considérés comme une version de pièce?
Ok. Ok, merci beaucoup. Donc, je vais répondre à la dernière question parce que je l'ai entendue. Ah, ok, merci. Pour la dernière question, est-ce que le gouvernement va nous autoriser d'utiliser la blockchain, c'est ça?
Ça veut dire que nous allons faire correspondre les industriels